Welcome everyone. This is our fifth sort of talk in this amazing grazing project with different topics. We've touched biodiversity and some multiple interests in our grazing lands and a bit about our grazing resources that are available in Norway. And now I'm very happy that Rebecca can have a talk for us. Fibershed is a partner in Amazing Grazing. And I'm sure you will tell more about the Fibershed, but from how I understand it, it's you, Rebecca, that established the Fibershed, and the issue of creating like regional textile economies and connecting these two. Also work with to mitigate climate change and restore ecosystems and connecting sort of the textiles and fibers to agriculture and landscape is the background of it. So I'm very happy that you got up early and it's 7 o'clock in California. But so please, I'm giving the word to you and let me know when to flip the slides.
Thank you so much. That was a lovely introduction, and hello everyone. So I'm joining you from North Central California in a region north of San Francisco, and we work in what we call 51 counties in California, and that region includes the United States' largest wool production landscapes and the largest extra long staple cotton production. And these are materials that go generally, I would say, in the wool system, highly underutilized. And in the cotton system, our cotton is actually exported. We don't have the ability in California to mill our cotton. So I was responding to those issues that we endemic and regional economies that supported our farmers and our rural working landscapes at all, especially in the fiber system. So Fibershed was a word I coined as an analog to a watershed or a food shed, to bring intimacy and care and concern to build up economies that are centered in ecology. The land never lies to you. The land always tells you how it's being treated. So if your textile culture comes from a land base that you can see, it's very clear and evident what's occurring. It's clear how the animal welfare system looks or doesn't look. Labor is being supported or not supported. Those things become community conversations in these more regional systems, and there's a power in that transparency. So we'll go to the next slide. And the work that we've done consistently, and I think why I'm so excited about Amazing Grazing and the work that you're all doing, is that we think about our work within the carbon cycle, and somehow the textile industry as a whole has centered its work less on the basic principles of hydrology or carbon cycling, and more on kind of like cherry picking what it wants to do to substantiate business as usual. But the reality and the very kind of brass tacks truth of how the earth is functioning is there's only 5 carbon pools, and how we dress ourselves, how we feed ourselves, it's affecting the transference of carbon between the pedosphere, the atmosphere, the biosphere. And in our textile system, we have a lot of inadvertent, and we're becoming more conscious of it, but we have a lot of inadvertent movement of material of carbon into our oceans, which is our largest carbon pool. And so we've done a lot of work and research in our community on the landscapes that we don't irrigate. So California, as you know, has a very dry season and a very wet season, but it's in the dry season when a lot of our agricultural crops are grown because the climate is so temperate. It can grow an extra long staple cotton, it can grow an almond, it can grow a pistachio. These materials that require long growing seasons without frost. And so what we've been looking at on these unirrigated rangelands, so we love the landscapes that we don't need to irrigate because water is very sensitive, our hydrology is very sensitive. So we looked at, how do we enhance carbon? Carbon's always moving between the soil, biosphere, and atmosphere. It's always in flux, but we're looking for a net improvement, you could say, or a net movement, a net positive or a net negative, whatever, depending on your perspective, but a net negative movement of carbon into the soil. So we work with UC Berkeley on what do compost applications on our rangelands do? What's the life cycle assessment for that compost? How does it function once applied to unirrigated rangelands where sheep are grazing? And we found some really wonderful responses in our rangelands to adaptive managed grazing, which is the grazing that responds to the flock's vegetation management. So making sure we have a lot of residual dry matter left, making sure we're moving the flocks quickly through the landscape because we're in a semi-arid system. They can create erosive conditions very quickly if we don't move them. So it's not it's not the inherent reality of grazing that's an issue, it's how we're grazing. And so we combine that with also thinking about compost applications, because our rangelands have lost since so we have a huge debt in California to the soil. We have been letting that soil oxidize carbon now for 500 years. And so we have a lot of carbon we need to put back, and grazing rangelands and many other practices that we do in the grazing system, like compost applications, are really important to us balancing the carbon cycle. Next slide. And then we also think about the clothes as carbon, right? So there are fresh forms of carbon. They are materials that are produced during an annual rotation of the Earth around the sun. They are, carbon driven into plant material by the sun's energy. We think about that as biosphere-based fresh carbon. And that carbon we think about as moving back into the soil upon every time you try to mend your clothing and you upcycle. We do all these things to keep the clothing in play, but if it can no longer be worn, we want to ensure that it can become food for the soil at the end of its life. And this is not the way the textile industry is designing. They're not designing for decomposition currently. There's a lot of work to be done, and I do believe that work done at the regional level is going to be very, very important, because it's going, designing for our own soils, designing the farming systems so they can be more enhancing of photosynthetic carbon capture from the atmosphere, designing our manufacturing systems so they're ecologically sustaining, and then designing our composting systems at a regional scale. It also supports not using as much energy to move what is now a globalized system of materials through countries. I don't think we're going to be moving all of our clothes over to another country to compost them. We would like to see that done in situ. Next slide. And then in our San Francisco Bay, we worked with the Estuary Institute, and it was determined that the 54% of all microplastics in the San Francisco Bay are microplastic fibers. And those are entering our San Francisco Bay through stormwater events. And that's because the dryer lint is landing on sidewalks. And when the rain events come, the plastic lint from clothing is entering the bay. So there were many people who said we should put filtration systems on our washing machines, but our American appliance industry has recently stated that that's not going to be an effective way. They clog, and they use more energy when we put the filters on. We just saw those comments come back to our National Oceanic and Atmospheric Association. We have a large Environmental Protection Agency paper that's being written right now. And the appliance industry has really pushed back and said, if you wanted to use, if you want energy efficiency appliances, if you don't want these things to clog, you're going to have to reduce the source of these plastic emissions, which again just points to the role of wool and the role of natural fibers that have a biodegradation pathway. I know there's a lot of chemistries we apply to natural fibers, and those too need to be very looked at, because those are also an issue for our marine ecosystems. So next slide. And this is the landscapes that I had mentioned where our wool is produced. These are landscapes where we're doing practices not just to enhance the efficacy of how well the animals are moved through the system, but in addition, we're putting silvopasture in. We're putting, like in this upper right-hand corner, you see redwood trees being planted. Those will be shade-producing trees for the sheep. The upper left, you see what we call a beaver analog. So what we're trying to do is build out a little willow dam that will slow, spread, and sink water during rain events, because we are getting much less snow. And so our snow is becoming rain. And so we need to sink the rain, plant the rain, they say, in these semi-arid systems. And beavers used to do that work, but they were almost completely extirpated from the landscape. And we're starting to now see our state of California bring back funding to restore beaver habitat. And so these analogs help establish beaver habitat. So eventually we would reintroduce the beaver into this sheep ranch. And then you see examples, those are small photos, but you see examples of us putting in the center upper photo, that's 100 acres of riverfront where the sheep are grazed, and there was what's called a riparian herbaceous cover, and it's putting wildflowers and native forbs and perennial grasses back in the system. So each one of these photos they're not the most easy to see from where you're sitting, but all of these are restoration efforts going on, or compost being made for an application onto a rangeland, or a native seed planting with a no-till seed drill, which you see in the far bottom left. And all these practices are paid for through two mechanisms. One is our Healthy Soils program through the state of California, and the other is the actual textile brands who are purchasing the wool now from our region, and they're putting a premium on that. And that premium is being used by the rancher. We have an agreement with the rancher that they'll use the premium to support the enhancement of the ecology on the landscape. Next slide. And those are the practices that we've invested in. There's, I think, 32. All of them are also known to help enhance photosynthetic carbon capture. Next slide. You probably know this because you are the Amazing Grazing Project. So we've been looking at how animal integration into a cropland or animals grazing on the unirrigated rangelands of California. What is the mechanistic ways in which carbon sequestration works? And so this graphic was done by the Plant Sciences Division of University of California, Davis, one of our land grant universities. And again, this idea of establishing a virtuous cycle, the balance of carbon inputs and carbon losses, supporting soil ecology. Microbes are really at the center of this conversation. What you're seeing here, the student I worked with who just finished his PhD, he made this graphic, and he's trying to show the microbial carbon pump. He's saying, this a way of feeding the microbes with the manure that ends up on the soil surface. It's important that microbes have access to that form of carbon. It's very available to them. So we'll go to the next slide, and I can share his scientific paper. So here it is, the sheep in the upper left, and so this is an example of a sheep grazing in just a grassland. But there's these different ways in which carbon enters into the soil system. And through this, the back end of a ruminant animal, we see the manure providing a potential for dissolved carbon, igniting the microbial carbon pump in a way that activates with I would say he would call it a very efficient way to get carbon into the system and
Så det er mye som foregår parallelt, så det
community. Again, this is going to be, our measurements are about carbon flux, because obviously when we have more microbes active, we have more carbon moving up, but we also have more carbon moving down. It's just enhancing an entire flux cycle. But through other processes, mineral stabilization, we see that we do end up with soil organic carbon that in aggregate is stable and not labile. So the enhancement of non-labile carbon is something. There was a net increase in non-labile carbon in landscapes where he studied, where sheep were grazing in some of our croplands, specifically in our vineyard systems. So we'll go to the next slide. Oh, and that's just a goat in a rice field. That's kind of random, but I did want to add it in because we do love animals in all of our croplands. We put them everywhere we can. So we'll go to the next slide. And that's the system where the microbial carbon pump was being studied. It was moving sheep through the vineyard systems. We'll go to the next slide. Oh, that's the same sheep. So when they're not in the vineyard, they're getting moved around oak woodlands to do a reduction in these grasses you see in the foreground. Those are, we call them a European oat. I think they're originally from Spain. They came during the Mission era, and it's a grass that is annual, and we really try to get it grazed down because it goes senescent and gets very dry, and it's a fire igniter in California. So the sheep are really helpful in suppressing the effect of the European oat. Next slide. Oh, I guess this, I'll just add to this. I can send this to you. This is just more how the sheep are supporting us and becoming more fire safe in our communities. So it's beyond, it's a bigger carbon cycle implication, I know, for your study, but to think of us moving out of, in California, of catastrophic fire and moving into slow, low, smoldering fires for our grasslands. Our grasslands will burn, but how they burn and the catastrophic or not catastrophic nature of those burns is mission critical for all of us living here. And animals are a huge part of us working proactively to mitigate catastrophic fire. And this is an anthology from my community of all the people who lost their homes in these larger fires and wrote about their re-engagement with their landscape. They did not move away, they stayed, but they brought animals into their neighborhoods to graze down the vegetation at certain times of year. And it has really re-inspired their ability to feel confident to live where they are. And it has also healed them in many ways because animals have brought a sense of presence of mind to them. And they write about this in this anthology. It's a group of neighbors who wrote it together. Okay, next slide. And this is some of that work of just sort of thinking that, remembering that animals are helping us on those larger carbon cycles, are the understories of our forested systems, just gently grazing some of that. We have a lot of Himalayan blackberry and a lot of plant life that is not endemic to here. It gets into the trees. Having the animals help us do that work. And then also working with indigenous fire ecologists and doing some work with fire, but we call it friendly fire, not devastating fire. Next slide. And then I'll just, I think I'm almost done, but just wanted to share the cotton system. So we're doing an experiment in those green strips. The San Joaquin Valley in California is where 80%, I think, of the world's almonds are coming from. It's a very industrial, highly engineered system. It's a system that's actually in retreat. There will be less land farmed because of climate change, and we're funding farmers to do different things with their land. But there are farms that we know will remain, and so we're trying to work on those landscapes to see a better way forward. So you'll see a little band of sheep. There's a little white cluster of sheep on one of those green strips. Yep. That's the animals grazing down the cover crop. So in a semi-arid system, which you don't have in Norway, but it's important for the animals in our region to be out in those rangelands and then be able to move into cropland residues so that we don't overgraze any one of these systems. So our system is croplands, semi-arid rangelands, and they rotate through on an annual basis. And right here, they're grazing down a cover crop that we put in that's about to become a cotton system. And then the dark brown areas, those are the areas where cotton would normally be planted. And so we're trying to put in multi-species cover, integrate animals, reduce herbicides, eliminate pesticides, and the animals are a key part of how we regenerate our annual croplands. In this case, this is a research project we're doing with another university. The next slide, I think. Oh, yep, is it going? And let's just go, oh, that's them again. That's a good one. And then we'll go to the very, I want to get to the photos of the, sorry, there's a lot of slides in here. We'll go to the photos of the wool garments to just, oh, that's our math on all the practices that our growers are doing. Most of our work is in prescribed grazing. That's where we're seeing most people activate in the rangelands and do really good work with moving the animals around and restoring these ecologies with the beaver analogs and the shade points and all of that. That's part of that bigger work. So you'll see most of our growers are involved in grazing. It's a grazing-centered farmer rancher community. Next slide. And this is some of the math that we work with Colorado State University, and this is us working to understand the impact of a few of these growers with the CO2 that's not labile, the net figure of additional carbon that's beyond business as usual, not what they would normally do, but what they're doing in addition with their grants and their price premiums. So what's that additional carbon math? That's what this slide is. I'll send you this if you want to review it in more depth, but for the purpose of time, we can keep moving to and this is the work that this slide precedes the images of the textiles. So this is how the climate beneficial system works, is that we want carbon and money to track together. We want to enhance the movement of carbon into our soils. And so we have, again, price premiums that are offered to the growers in combination with state grants, so they can do beyond business as usual work. And then that work ends up, the sheep are sheared, and we do work with as local a supply chain as we can. Very difficult, I will say. And then the next slide. This is a brand out of Los Angeles. And you can go to this website. It's climatebeneficialfiber.com. We started, we're a nonprofit organization, Fibershed is, but we partner with different agricultural co-ops as well as for-profits that can help do the business side of the work. So we pool our wool together and we make it more accessible for brands. And so a list of those brands is on the Climate Beneficial Fiber. I think it's climatebeneficialfiberpool.com or just climatebeneficialfiber.com. Next slide. And these are more of the brands. So the wool is used for bedding. The wool is used for durable goods like blankets. The finer counts are used for coats, sweaters, hats. And then I think the next two slides might just be an illustration of some of our goals. Oh, more clothes. Those are all brands working with our community of growers. Next slide. And this is what we envision. So I've kind of given you all these photos of snapshots of what we're trying to do, but to synthesize, we want to see these landscapes include small scale. I don't know if you would even call it small scale. On the world stage, it would be considered small. But for our region, it would be considered medium to large scale or boutique size mill. We would like to see the placement of some of our facilities to manufacture our fibers more locally. And of course, we would want them to be powered by renewable energy. And here, this is just an image showing that intersectionality between the oak woodlands that California is so famous for. We have 19 species of oak. We have a beautiful oak savanna and grassland, very effective climate change. So the role of thoughtful and prescriptive grazing in that oak woodland to enhance the perennial grasses, to reduce the seed bank of the annual grasses, to restore those systems and to make them less vulnerable to catastrophic fire. And then to see that in concert with a local economy that substantiates itself off of, the ability to wash the wool and spin it and knit it, and then to have the community have the clothing be accessible to them. I think the main thing we realized is we just need more sovereignty in accessing our own materials. We don't have that as much as we would like. It's very rare to find someone in California wearing a California wool sweater, even though we're swimming in wool that we can't do a lot with right now. So this is a vision of the future. And then I think the last slide shows that vision in our cotton systems. For the cotton will continue to grow, where we want to be able to also add manufacturing and center that in our rural communities. And I think that really is it. So I'll stop there.